In this video, we will introduce you to the CFD coupling alternatives available at Rocky. The DEM CFD approaches available in Rocky make it possible for users to model the simultaneous flow of fluids and particles common in many processes across multiple industries. It captures the discrete nature of the particle phase while maintaining computational tractability. Here's an overview of all the possible coupling approaches available that may suit the particularities of your project. There are 3 coupling options available in which external CFD solvers are not required. They are the one-way constant unresolved, the SPH, and the lattice Boltzmann. And there are methods in which particle-fluid interactions are computed by leveraging both Ansys Rocky and Ansys Fluent solvers. Now let's get into the specificities of each DEM CFD approach. Starting with the one-way constant method, which simulates how a constant fluid flow affects particle motion in Rocky. It is useful in cases where you have a known, unchanging fluid flow and want to understand how it impacts the flow of particles without having to use a separate CFD software. In one-way Fluent, we have a method accomplished by coupling with Ansys Fluent. The flow properties throughout the equipment being studied, such as velocity and pressure, will be computed by Fluent and exported to a Rocky-compatible format. This method is particularly useful for simulating the effect of water on the movement of particles through a pipe, for example. While the fluid data must still come from Fluent, with the one-way Fluent method it is not necessary to have both Rocky and Fluent installed on the same machine. There's also the two-way Fluent transient method, in which the particles are considered to affect the underlying fluid flow. This unresolved method is particularly useful for simulating complex phenomena. The particles are small compared to the cell size of the CFD mesh. Another two-way method is the two-way Fluent semi-resolved, which solves cases where the resolution of the fluid flow around the particles is critical to capturing the behavior of the particles or their effect on the flow itself. It requires a fine mesh in order to properly capture flow properties on the particle surface. The finer the mesh resolution, the more accurate the results, but also, the more computationally expensive the simulation. Back to methods that only Rocky is needed, we have the SPH method, Smooth Particle Hydrodynamics. This is a Lagrangian method in which there's a two-way interaction between particles and fluids. Apart from being recommended for free surface flows, since this approach is meshless, it is a good alternative when complex or moving parts are present. This method does not require any external solver. For more information and example applications, watch our Ansys Rocky video, What is SPH? And to finalize, the one-way lattice Boltzmann method, in which particle flow affects the fluid flow but the fluid flow does not, in turn, affect the particles. It simulates the airflow resulting from particle motion, which is useful, for example, to investigate how to mitigate dust generated out of a transfer chute. And here's a brief summary. DEM CFD coupling models the simultaneous flow of fluids and particles. At Rocky, we have 3 methods which can be solved using Rocky's solver only, and 4 methods, both in one-way or two-way capacities, that require both Ansys Rocky and Ansys Fluent solvers. To learn more about CFD coupling methods, check out other Ansys Rocky videos and resources.